So in this video, we want to find the area of a regular pentagon, five-sided figure, polygon. So find the area of the regular pentagon with side length of 20 inches. And the formula we're going to be using is the area is equal to 1/2 AP, where A is the apothem and P is the perimeter of the pentagon. So remember, for a regular polygon, in this case a pentagon, all sides have to be the same length. In this case, each side is 20 inches, and every angle has the same measure. Talked a little bit about this in an earlier video, so let's just proceed. Here's what we have then. So again, we have a pentagon here, 5 sides, every side is the same length. So this is 20 all the way around. We have 5 sides, 5 angles. Divide 360 by 5. We get 72 degrees. Every angle then has a measure. This angle here, this angle here, here, over here, and this one is 72 degrees. Now the apothem, as we mentioned last time in the earlier video, you draw a perpendicular from the center of the pentagon. So that would you say somewhere in here, and draw it to any side, opposite side. So in this case I do it to the base here, and this divides that side, or bisects that side, into 2 equal segments. So each side is 20, so this would be 10 here, inches, and this would be 10. And this would be a 90-degree angle right here. So this would be the apothem. Now this segment that I drew here to the vertex, and I can draw some others over here, is the radius. Because you can think of this pentagon as being inscribed in a circle. So if I draw a circle, I did this I think in the last video, something like this. This circle passes through the vertices. The distance to each vertex would be r. So this would be r, or the radius of the circle. But here we're concerned about the apothem. It tells me that the area is given by 1/2 the apothem. We don't know it yet, have to find it, times the perimeter. The perimeter we know, because each side is 20. 20 times 5 is 100. So the perimeter is 100 inches. So that's what we have. Just clear this and go to the next diagram that I have here. And this is what we're going to use. So see, I drew the radius to each vertex. So you can see there's 1, 2, 3, 4, 5 triangles. So what happens here then, like I said, this side is 20. But when I draw the apothem from the center to the opposite side, this is 90 degrees. So this angle right here, right there, is 36 degrees, bisects the central angle, which is 72. 72 divided by 2 is 36. And of course, since it's 90 degrees here, the other two have to add up to 90 degrees. So if this is 36, the other one has to be 54. And this is the apothem right here. So let me look at this from this perspective so you can see it a little bit better. So I'm going to draw it this way. I'm going to turn the triangle in this format so that this would be A here. That would be A. The 54 would be over here, and this here. And this angle here, which I'm not going to use here, would be the 36. So I change the orientation of the triangle. So from this, here we have a right triangle. You're going to use a trig function. In this case, a tangent function is the opposite side over the adjacent side. So remember that this side here, if I look at this, this is 20. So this apothem bisects that side, so this would be 10 here. Everything else, like I said, this is 20 inches and so on all the way around. But I'm going to be focusing on this triangle right here. This triangle right here. And I change the orientation, I put it over here. So then I can say that the tangent of 54 degrees is the opposite side. That's the ratio for tangent, opposite the angle over the adjacent side. The adjacent side is 10 inches. So we'll get A equals to, then multiply both sides by 10. This will be 10 tangent at 54 degrees. And then we just use the calculator here. Some you can get away without using using trigonometry, using Pythagorean theorem and special triangles, 45-45 triangle, 30-60 triangle. But eventually you'll have to use trig. So let's just say then, make sure your calculator is in degree mode. Check the mode here, this one's in degree, so no problem there. So then I just hit the tangent. Well, let me say 10 times the tangent. So 10 times, and then tangent of 54 degrees. Close the parentheses. Notice I don't have to put degree here in the 54 because the calculator is set to degree mode. So it knows if I put 54 there, it knows it's 54 degrees. So the apothem then comes out. I'm going to round that out to 2 places here. 13.76. So now using the formula, the area of the pentagon, it's a side of 20 inches, is 1/2 times A. A is the apothem, so in this case, it turns out to be 13.76. And this is times P, or the perimeter. So we're given that each side is 20. There's 5 sides in the pentagon, so 5 times 20 is 100. Okay, so this is your perimeter. And then you just multiply this out. 13.76 times 100 divided by 2. And this comes out to 688. And this is square inches. I just write it as inches squared. Now you could also just say, focus on this triangle right here. That's one way to do the problem. But we could do it also by saying the area then is going to equal to, and just find that we have 5 triangles, so let's just find the area of one of the triangles. So let's look at this one right here, except in this case we're going to look at not this little one here. We used the little one to find the apothem, but now the apothem can be the altitude of this larger triangle, this central angle here of 72. So the regular formula is 1/2 the altitude, when in this case turns out to be A. So let me just do it this way. I know what that is, so I can just say that the apothem is just the altitude of this larger triangle, which has a central angle of 72. And that, of course, is, again, 13.76 times the base. So I'm just using the regular formula to find the area of the larger triangle there, 1/2 the base times the altitude. So in this case, the altitude H is the apothem, which is 13.76, and the base, now the base here is 20. So this is times 20. Now, if I was to do this calculation here, this would give me the area of this triangle right here, the bigger one. But then I have 5 of those, so I multiply this by 5. So I calculate the area of one triangle, and then I've got 5, multiply that by 5, and then of course that's going to give me the same thing, because you can see 5 times 20 basically is the same thing as the perimeter. So it's just another way to interpret this formula. I still get the same answer, 688 square inches. So take your pick on that. Of course, you've got to be careful. Sometimes an instructor will tell you, use this particular method, and they want you to do it that way. So if they don't specify, they just say find the area, then you got your choice. Thanks for watching. We'll see you next time.